Hello, I'm Paul and I'm the Product Director of Artificial Intelligence and Machine Learning at Forsta. Today I'm going to give you our perspectives on how we see generative AI, its role within insights platforms, and what we have learnt by keeping the role of the human at the centre of the application of this technology. For those who don't know us yet, Forsta is the leading experience and insights company with a platform that enables you to understand what we call human experience. That's your customer's experience, your employee's experience, a product experience, brand experience, and more. We do this for thousands of the most respected and well-known companies throughout the world. When we consider the application of generative AI to the research or any industry, there is clear potential to significantly enhance productivity and creativity. To get the most out of the tools, the mindset needs to be one of collaboration, sharing outputs and maintaining oversight, rather than simply handing the task over to the black box and blindly accepting that the output is completely valid. Using AI for answers is like relying on GPS to navigate a complex city. The map provides clear routes and directions that appear reliable and logical. However, the actual best routes need to be insights from an experienced local guide. The guide's knowledge of the city's nuances, shortcuts, and potential obstacles is essential in ensuring that you reach your destination efficiently and effectively. AI is incredibly strong at generating plausible answers. It takes human input and experience to question the plausibility and adjust the correctness of the information provided. We've all seen tales of crazy situations that people end up in when blindly following sat-nav instructions. And if you're like me, you'll see a picture like on the slide and you'll think, at what point did the driver consider that the plausibility of this route may not be as cast iron as the software would have you believe? As data professionals, many of us already have the skills to question and check the rigour of our conclusions, and working with the outputs of AI is no exception to this. Understanding the strengths and weaknesses of the tools in use can help set up the success in applying to research problems. Recognise that AI tools excel at certain tasks, such as generating ideas, providing suggestions, or automating repetitive processes. Right now, AI is not a reasoning machine. By accepting the strengths of AI, humans can focus on high-level thinking, problem-solving, and decision-making. Considering the end-to-end process of collecting data, analysing results, and acting on insights, there are plenty of areas where AI and machine learning can be applied. Keeping a focus on the application of text-centric large language models like GPT, and considering the strengths highlighted on the previous slide, let's consider some possible applications of this technology to each stage of the research process. To reiterate, the tasks most naturally suited to large language models are summarization, editing or rewriting, idea generation, question answering, search and suggestions to structured entity generation, such as programming problems. For survey and data collection, AI assistants can be used for creating surveys more effectively by using natural language prompts to specify the target audience and desired outcomes. It can also be used to improve the quality of responses by using AI to detect patterns that could indicate fraudulent respondents. Also, increasing the engagement and response rates of survey takers is possible by using AI to drive a more conversational survey experience, resulting in a shorter length of survey to uncover the key issues. Analytics is where the focus of traditional machine learning techniques have played a part, and generative AI can also feature here by working in combination with these existing applications. One obvious use case is in the well-established practice of text analytics. AI could be used to support a more organic identification of common themes within comments, which may not exist within the structured categorization ontologies. The ability to link feedback to specific individuals can be used to drive employee recognition programs or uncover opportunities for coaching. These processes can be set up to continuously analyze patterns of trending data and to detect valuable signals, such as outliers or spikes, that may otherwise remain hidden. Workflows acting in real time can be used to trigger alerts to those who can act on these insights. Today I'll be mostly focusing on the impact that generative AI can bring to data exploration and insight generation. Examples include using search for insights in the data in the same way you would ask an analyst a question. For example, how do different age groups perceive my brand? This dynamic data exploration empowers business users to discover relevant insights without having to navigate through pages of dashboard visualizations to uncover the story behind the data. Finally, when utilising data in a customer experience context, one may use AI to assist in the generation of suggested responses or actions when closing the loop with customers. This was one of the first areas that Forsta used the application of generative AI and is a common simple use case. So we'll take a further look at this in the next section. One of the first cases that Forsta applied generative AI was within our reputation management products for responding to online reviews. Previously, responding to a review was supported by a customizable library of templated responses. Response reviewers needed to take care to correctly customize and vary template responses for individual reviews whilst mitigating repetitiveness. To reduce some of the cognitive load, we turned to generative AI to explore solutions. Work started earlier in the year, so at the time we used GPT-3 to generate a suggested response to the review. This suggestion would be presented to the response viewer for any further edits before sending, in keeping with the use of AI as a support assistant. During the development of the solution, we encountered a few interesting observations outside of the efficiency gains. One such observation was how much of a human touch these responses seemed to generate. Because each case would generate a new response from scratch, there was sufficient variety in the responses for them to appear unique, and the response would reference particular things mentioned in the initial review that gave the responses relevance. The solution allowed us to capture from a reviewer whether the provided response was good or not, providing us with further data to fine-tune the model for improved output. Through measurement, about 80% of the responses in the first iteration of the solution were judged to have created a well-crafted response without the need for further editing. Part of the reason for a high success was spending a significant amount of time exploring the effects of prompt engineering on the quality of generated responses. We were able to fine-tune the output by focusing experiments on varying the voice and tone of the prompt, providing prompt suggestions to influence the prompt response, such as mention that we would like a follow-up, and finally presenting context. Showing, not just telling, is often the secret to a good prompt, so by informing the model of the purpose of someone providing a review and who was providing the review would shape the output. Prompt engineering is an emerging skill in itself, and is another example of human-assisted intelligence working in tandem with the strengths of generative AI. The most important stage of the process is to clearly define the objectives and parameters of the task at hand before engaging with generative AI tools. Establishing specific goals and guidelines ensures that the AI assistant understands the context and produces outputs aligned with human expectations. By providing explicit instructions and constraints, humans can guide the AI tool's output in a way that aligns with their vision and requirements. For our second use case, we wanted to experiment with how an AI assistant could be used for exploring insights within survey data. The goal here was to have an insights assistant that the user could ask an analytical question of the data using natural language, and then a visualization could be returned that sought to answer the question. Given the capabilities of generative AI with text data, we used a relatively simple survey containing some KPI and attribute scores, structured profiling and demographic data, and verbatim comments as the source. Part of the goal was to support the quantitative insight with qualitative examples. For the proof of concept, we used approximately 100,000 responses. Comment data was processed for sentiment and categorization by our NLP engine for use within the exploratory analysis. To clarify, for the purposes of this experiment, we focused solely on the querying and insight generation stages, and did not use AI for the purposes of text analytics, given the strengths that our current tool had for this particular part of the processing. As mentioned previously, generative AI skills do not currently lie in reasoning, but like in similar use cases in the software industry, we could use OpenAI here as a translator of a natural language statement to generate a structured query. Let's take a look at the steps that we took. The first element of the exploratory analysis we wanted to experiment with was how humans could ask a question of the data in the same way they would speak to a colleague. The goal of this being to broaden the availability to extract insights from data without the technical skills needed to perform data analysis using traditional tools. Here, we used a multi-stage process. The user-entered description is combined with information about the data table schema, then submitted to the large language model. Based on the prompt, the large language model generates suggested SQL that will compose data to help with the analysis presented in the user description. Next, this AI-generated SQL is normalized to the expected response syntax using another large language model technology, semantic similarity. String literals created as part of the AI-generated query are replaced with similar values drawn directly from the underlying data, so that the SQL query becomes a good fit in structure and meaning. An appropriate chart type is selected based on detected groupings and value series, and displays the result. Finally, the query used is translated back through the large language model and displayed, so the user can see how the output differs from their inputted question. An example of a difference may be that, as part of the semantic similarity processing, band groupings may not have existed for a particular query. So asking for 30-year-olds may have resulted in a category selection of 29 to 35-year-olds. That adjustment is displayed back to the users in plain language for transparency. The survey responses belong to the resulting groupings are submitted to the large language model for summarization. This creates an overview of the responses inside each grouping. In the example on the slide, we are breaking out the topic from the original query into positive and negative sentiment. Other splits are possible depending on the natural language query. Finally, as part of the summarization, we asked OpenAI to provide some potential recommendations based on the findings from the comments that would support improvement. On the whole, the proof of concept yielded good results. The queries tested had a good match with the selected output, and spending some further time on prompt engineering on both the summarization and initial query stages, we were able to improve the output. One area that needed a bit of focus on the query side was working with dates to match the natural language statements. One other area of improvement was regarding the recommendations. This was a part of the workflow where we were asking for generative suggestions so plausibility traps can arise. One way to improve this is to look at providing best practice libraries as input for context to help focus output. So, from our own experience and market trends, where do we see the use of AI within the insight space evolving? Only a fool would attempt to predict the future, given the explosion of AI in the space of this year alone. So, here goes. Model innovation continues at pace. The general availability of GPT-4 brought about a step change in terms of the number of parameters. Then, at the end of July, Meta released the open source large language model, Llama 2. We're seeing more tooling to support data analysis. OpenAI launched the ChatGPT code interpreter plugin to paid subscribers. I'm sure a few of you have checked out the videos of ingesting, then generating Python scripts to analyze data based on prompts, and how this opens up new routes for exploratory analysis in a similar fashion to what has been presented today. The debates on privacy, IP, and ethical concerns are only just warming up. In the US, at the end of July, a group of the 7 largest companies have signed up to voluntary safeguards, but it remains to be seen whether self-regulation would be considered enough. Copyright cases are emerging, with the likes of Sarah Silverman challenging whether their works have been used as part of training content without their explicit consent. The situation will continue to evolve and is likely to remain messy for some time. Some companies are now taking direct action and banning their employees from using openly available tools, like the example from Samsung earlier in the year. It is difficult to see how to put this particular genie back in the bottle, but these concerns may generate a shift towards proprietary models, especially for sensitive industries such as healthcare. Ultimately, we need to consider the relevant application of these tools to our own industries. Whilst these broader tools and their capabilities are impressive, we believe that many meaningful advances will be made around narrower, domain-specific large language models, and the combination of these with existing NLP and machine learning techniques. By integrating machine learning, natural language processing, and data visualization techniques, researchers can create a holistic framework that amplifies the capabilities of generative AI tools. This mixed approach allows for comprehensive data analysis, going beyond the surface level of questioning data and driving intelligent automation and dynamic visual representations, resulting in more accurate and actionable insights. Just like with human collaboration, the best results come with building context and guardrails. Insight platforms such as Forsta are well placed to develop solutions that can distill context around who is looking at the data, as well as additional metadata on the collection process and the methodologies that can enrich the analysis rather than shoveling CSV files into the black box. Insights platforms can succeed by embedding AI as part of the end-to-end process rather than a specific task. Each step can enhance the next along the data journey through gathering, analysing, visualising and acting on insights. And as we have seen today, an essential element of this success is keeping the human at the heart of the process.